Welcome back, Math 136 students. Today we're going to talk about complex numbers. So what you've experienced so far in our lessons is that we can solve equations in a set of real numbers, which means that we have solutions to equations which are real numbers, and then we have solutions to equations, or rather we solve equations, and through the process we find out that there is no real solution because we run into an issue. And that issue, or at least one of those issues, happens to be illustrated right here, that there is no real number for which x squared is equal to -1, meaning that there's no real number that we could substitute for x squared, or for x rather, square that value and get -1 as a result. It just can't happen, because any positive number squared is a positive number, and even any negative number squared is still a positive number. So this results in a whole nother set of numbers that are not real, and we call those numbers imaginary, which then lead into complex numbers. So first, the definition of an imaginary unit. An imaginary unit, which is designated with the letter I, is the number whose square is -1. So what this means is that I squared is equal to -1. And just as important, that means if we square root both sides, we have I on the left side and we have the square root of -1 on the right side. So we have two important pieces of information which you must know throughout this lesson and going forward in algebra. And that is that I squared is equal to -1, and also that I is equal to the square root of -1. And this leads directly into our definition of complex numbers. So complex numbers are of the form a plus bi, where a is the real part and bi is the imaginary part. So just to illustrate real quickly, up to this point you've worked exclusively in the set of real numbers. So you've got this set of real numbers. Let's just say this box represents the set of real numbers. Okay, now we find out that we have this complementary set that is not necessarily real. So we'll put it off to the left here, and we call that the imaginary set. And then on top of all that, we've got a set of numbers that encompasses all numbers, meaning all imaginary and real, and we call that the complex numbers. Okay, so basically, if b is 0, then all you have is the real part a, and which means that this is only a real number. If you have a, which is 0, then you have only the bi, which is an imaginary, and if you have both a and b in your number, then you have what's called a complex number. In the complex numbers, we can do all four basic operations, and to do this, we treat I almost as a variable until we have simplified as far as we can, and then we do anything we can to simplify I if at all possible. So remember two important things. I is equal to the square root of -1. So if you have I when you've simplified, there's nothing else you can do with I. You have to leave it alone. However, if you through any of these operations get a product of I squared, this does in fact equal -1, and so you will do some substitution to simplify further. So for example here, I have 4 plus 5i plus -8 plus 2i. So the real parts can be added together, so 4 plus -8 is -4, and then you can add the imaginary parts together, so 5i plus 2i to get a positive 7i. Now, because I is square root of -1, and you cannot multiply 7 times the square root of -1, we leave it as -4 plus 7i, and we're done. Now, number two, we're going to distribute these two binomials, just like you would if these were two binomials with variables x or y or something else. So we'll take these two terms and multiply, so we'll get -6. we take these two terms and multiply, so we get positive 8i. We then take these two middle terms here and multiply, and that results in a product of plus 18i. And then we take these two last terms and multiply, and that will result in a negative 24. And this time I squared, because I times I is I squared. Now we want to simplify, if at all possible, and it is. So first thing you hopefully notice is that these two middle terms are like terms. So we have negative 6, and 8 plus 18 will result in 26i. And then you have minus 24, but wait a minute, we knew from earlier that I squared was equal to negative 1, so I'm going to substitute a negative 1 for I squared. Okay, so we're still not done because of that. So we now have negative 6 plus 26i plus 24, and now we add, that's the negative 6 and the 24, and that will give us positive 18 plus 26i. Okay, the next problem is a little different. So just like if we have an irrational number in our denominator and we try to rationalize that denominator, if we have an imaginary part in our denominator, we also want to turn that into a rational number. To do that, it's almost a very similar process. We will multiply by the conjugate, which is 7 minus I. And whatever we do to the denominator, we must also do to the numerator. So go ahead and distribute out. So in the denominator, it's going to be 49 minus 7i plus 7i, and then it's going to be minus I squared. In the numerator, it will be 7. It'll be minus I minus 14i, and then plus 2i squared. So similar to what we did in problem number 2, we must continue to simplify. I'm going to do a lot at once. So we notice here that the I terms in both the numerator and denominator can be combined. So 7, that'll become negative 15i. And I'm also going to substitute negative 1 for I squared. So this will be 2 times negative 1. In the denominator, what you notice is that the I terms actually do cancel out. So we have 49 minus a negative 1. Okay, and that should happen every time, because again, in the denominator, you do not want any I terms left once you've simplified. So we're going to do this one more step. So 2 times negative 1 is negative 2, plus 7 is going to be 5 minus 15i. And in the denominator, sorry, I'm running out of room, we have a 49, right? That's a horrible looking 49. Sorry about that. So we have 49 minus a negative 1, which really turns into 50. Now, finally, we should simplify this since we have a common factor in all parts. Now, remember, to simplify this, we must have a common factor in all numbers in the numerator and denominator. So in this case, we have a common factor of 5, so it'll be 1 minus 3i over 10. And that's your final answer. The last problem is asking us to simplify this radical. So what I'm going to do is break it up into lots of parts so that way we see clearly how I'm getting this. And going forward, I might do this quickly in fewer steps. So the first thing I recognize is that a factor, 40 has a factor of 4, which is a perfect square. Since it is a negative 40, it also has a factor of negative 1. And then finally, the last factor is 10. So again, 4 times negative 1 times 10 is in fact negative 40. Now the reason I brought out the 4 is because it is a perfect square, so when I square root it, I get a 2. We know something about the square root of negative 1, and that comes from what we talked about earlier, that the square root of negative 1 is considered I. So now it's 2i. And then we have what's left, which is square root of 10, and that's our final answer. In the last problem, we are going to solve this quadratic. And what we experienced with solving quadratics prior to this lesson is that there were certain quadratics that could be factored. We could use completing the squares method, or we could use the quadratic formula. And we found that there were, in fact, solutions, but then there were some that we found out did not have solutions. So this is an example, or not a real solution, that is. This is an example of a quadratic that does not have a real solution. So because of that, we know we cannot factor this. So our two options are to complete the squares. It is the quadratic formula, but in this case, we also have the ability to just go ahead and solve it because of the fact that there is no linear term. So what I choose to do is subtract 4 to both sides. Then I have x squared is equal to negative 4, and I square root both sides, and so I have x is equal to, now don't forget your plus or minus, And what we saw, similar to what we saw with number 4, the problem number 4 we just completed, is that we can break this up into the square root of 4 times the square root of negative 1, which is plus or minus 2i. So our solutions are imaginary solutions, which are plus or minus 2i. No real solutions in this case. You could have also gotten this same exact solution by using the quadratic formula, or also by using the completing the squares method. But whenever there's no linear term, I recommend using this process because it's a little faster, but you don't have to. It's really your choice. All right, good luck.
Anywho, Wapadoo.